Okay, question number 9. All right, now it's written in this weird way, like maybe you're supposed to calculate them all separately and then wouldn't you have to use a binomial formula or something like that. It makes it look like it's a super hard problem to do because it has it as A, B, C, D. Okay, but really what it's saying is make this chart. N is 3, P is 0.15, make the entire chart. So question A is get the number for that part of the chart, get the number for that part of the chart. So it's written out in 4 things, but it's just get the chart. Okay, really A, B, C, D together says get the chart. binompdf, it's got to be PDF because that stands for probability distribution. Don't accidentally go with CDF. All right, now where do they put that? Because everything I'm like, oh, isn't it under stat? Everything's under stat, but it's not. It's under distribution, which is a bizarre place to put it. So I need the second function, and right there above the word vars is distribution. Okay, so that's what I need. It's in there. All right, now yours might start asking you questions, or it might just come back with this, like that's all I see on the screen. Okay, if it asks questions, the first one it asks is number of trials, which is 3, the number they give you. If it doesn't ask questions, 3 goes right there with the comma after it. And then it says probability of success or something like that. And if it doesn't ask that, actually that's the second question. 0.15. And then if it asks the third question is probability of success. It might not ask a third question because it might be like my calculator and just do that. But I don't need to fill that part in. It'll give me the whole chart. 3,0.15. All right, if I just quit now and hit enter. All right, 0.614125. 0.6141. And then 0.325125, and then 0.057, I'm going to round that up, and then 0.003, I'm going to round that up, 4. Okay. So I've just answered question A, question B, question C, and question D. Use the numbers you just generated as a probability distribution. Is getting less than or equal to 1 unusual? Probability of less than or equal to 1. This is a math question, not an opinion question. Okay. It's not supposed to be, well, it doesn't sound unusual to me. All right, it's the official word, unusual, in math, which we know is either 2 standard deviations or it's the 5% cutoff. Okay, either one of those rules is fine, and we figured out when we're doing these, the easiest one to do is to go ahead and use the 5% cutoff. Less than or equal to 1 is the probability of 0 plus the probability of 1. Now, I could probably have looked at this and told you that that's greater than 5%, but I'm just going to add it up anyway. 0.6141 plus 0.3251 is 0.9392. So you should go ahead and add that up on your paper, even though it should have been obvious a long time ago that that is greater than 5%. I don't see the number 5% anywhere in the problem. That's just when I wrote down the word unusual. That's supposed to bring the 5% to your mind because the word unusual matches up with 0.05. So it wasn't already in the problem. It was there embedded in the word unusual, and you had to know that. All right, but since this is greater than 0.05, you could call it usual, or you could say not unusual.